better now? Or am I the only one seeing it?
No, we can't.
You cannot. Okay. Okay, so what I'm doing is I'm multiplying 525.6, essentially looking at the wind speed of 3, is it 3? Yeah, of 3 meters per second. So that is happening for 525.6 hours a year. And I'm multiplying that with the power output I would expect for that wind speed, which is 38 kilowatts. And that gives me 19,972 kilowatts. And then I'll divide this by 1,000 to make it, sorry, kilowatt hours. And then I'll divide this with 1,000 to make it megawatt hours. So I'm going to get 19.97 megawatt hours. So like 20 pretty much when you round it up. And do the same for every one of the wind speeds which occur in that particular area where you're thinking of installing your wind farm. And then you really sum them up. So you take and you sum up, 0 with 0.2, with 2.5, with 20, with 40.5, and so on. So you sum all of these up, and what you get is a rough estimate, but not a very bad one, really, of the annual wind energy production you will get at a particular site. Does that kind of make sense for you guys, or it is all over the place? It's a very simplistic way of doing it, but you can do it in 5 minutes. This is why I like it. Is there anybody who doesn't have any idea what I'm talking about? No? Okay, so it's kind of clear for all of you. Okay. So that's a very simplistic way of making these estimations. Like I said, if somebody's paying a few billion euros or pounds to make this kind of investment, believe me, they wouldn't go with these tables, clearly not. Yeah, there is special intelligence going behind these estimations if you want to make them very accurate. But that will also cost, for this kind of intelligence. What I'm showing you is a way to have a rough figure, for 5 minutes, just, if you want to make an educated guess for what the output might be in these locations. There are a couple more things I want to show you before we go. One is that you might be seeing graphs like this one. So when you estimate certain locations, you will be seeing graphs of that type. And that's a graph where not only you get information about the wind speed, which is important, but also about the direction of the wind. So because that matters as well, and it matters not only in terms of how well your turbines will be turning left, right, or north or south or east or west or whatever. It's not just that. It's not just the orientation of the turbines, because that in a way it's also kind of manages itself, right? Turbines do understand where to turn to, and they do that automatically. So it's not necessarily such a difficult thing. But what that shows you is understanding these directions and then thinking about siting the wind turbines with these directions in mind. So for example, what you want normally, let's have a very quick think on that. So imagine you have a turbine and then you want to have a wind farm, right? So you need to have turbines near your other turbines. How near can you go? What would be your guess? So if I put a large wind turbine in spot A, how soon can I go? How near can I install my next turbines? So for example, if I show you this picture here, so you have one wind turbine here, how close is the next one, you reckon?
I would say the height of a turbine plus some margin.
The length of the height.
Okay. So let me just say, okay, first of all, again, there are very detailed landscape and wind speed estimators that do that, and they do that in an amazing way, where you see really out of the software coming directly a whole mapping of where your turbines should be and how you will maximize the output of the wind farm and so on. And it also depends a lot on the size of the turbines. And let me get to that right now. So it is indeed true, as both of you have mentioned, that the distance you have between the turbines depends heavily on the size of the turbines themselves. Typically, what you want to have is roughly a diameter of about 5 turbine rotors around your turbine. So that would be the kind of typical area that you want. So it is actually bigger than just the height. It's typically a little bit higher, a little bit, more distant than that. What is the reason why we need this kind of distances, you reckon?
Doesn't it change with the dimension of the turbine? I mean, I don't think it's always the same.
No,
exactly. And I also think we shouldn't make like a shield of the wind. I mean, if all the wind, I don't know, maybe a turbine in front of another can shield a bit of wind. So
correct. No, exactly. That is the reason why we need that distance is because, when the wind comes through the blades, part of the wind disappears. It's not correct to say disappears. What it does is it changes direction. So the wind crashes on the blades, gives some of its energy to the turbine that converts it to electricity, but then not all the wind continues directly behind the blades to hit the next turbine. A lot of the wind, the air that moves, changes directions and starts going basically at other directions completely. So it goes perpendicularly to the blades. Yeah, so that is typically what happens, which means
isn't it the same phenomenon that you get when two big buses drive one behind the other and you try to pass them? If you have an obstacle with wind, the wind would like change shape.
You have all of these types of aerodynamic effects. Most important here is that you need a bit of space between the turbines for the wind to gain, again, sufficient speed to be able to turn the next turbine. So that doesn't happen, immediately. So if you think of an extreme case, if you were to put the turbine just, 10 meters behind the other one, it wouldn't work. Yeah? The turbine would just be shielding a lot of wind from the ones behind it. So it is not just a function of the size of the turbine, but the size of the turbine is very important in making these estimations. The other function that matters quite a lot is the predominant direction of the wind speed. So to which direction you get most of your very strong winds. So imagine in the direction where your wind is very strong, you could be putting the turbines a little bit closer to each other. Because of that direction, you expect to have a faster acceleration of the wind speed, which will be sufficient to end up producing more energy with your next turbine. If you have a direction that the wind speed is not particularly fast, you might want to leave a little bit more space, because then that's required for the wind speed to hit a higher speed that is required. Now, like I said, all of that is a very complicated functional model, because not only you need to know that, you need to know at which particular wind speed your turbines will be turning the most, and what kind of turbulence they will be creating behind them, and so on. So it is a complicated modeling exercise. It's not something that me and you are going to calculate here in this class. That's way beyond our remit for this particular work. But I'm only showing you this just to get you to understand a little bit that that there is some modeling going on behind where these turbines are being located. Now imagine, in theory, for any wind farm, given that what you get as a developer is a field, is an area just, that has specific boundaries, really what you care about is your capability to shove in there as many turbines as possible. Not really as many turbines, but rather as many megawatts of turbines as possible. So it could mean many small turbines, or it could mean fewer larger turbines. And again, the optimization functions that you can run to understand what is the optimal size of your wind turbines in order to produce the maximum output in that particular location. Again, this is another modeling exercise that you need to be doing. and a fairly complicated one. It's it's not a straightforward thing to do on a piece of paper, but it does give you a perspective of the things that need to be taken into account for these exercises. So I'm quite keen to let you go already if you are content with what you've heard, but equally I'm happy to sit here and talk to you if you have any questions. If you feel guilty for keeping the rest of the class here with your questions, I can also respond to your questions in an email. So whatever you want. Okay, no questions. Everybody's very guilty. So what we'll do then is we'll bring this class to an end, and we will also do another thing. If you have any questions, of course, do drop me a line. I'll do my best to respond to you. The other thing is, because next week is our last week. If you have anything that you have expected to hear in this module and you haven't heard anything of, and you want to let me know that, for example, are you going to tell us anything about this or that we heard and we want to know more about, do drop me a line from now, maybe today or tomorrow or on Friday. So maybe I can have a little thing and I make sure that, at least I make a little bit of a reference to stuff that you're interested in, and you make sure we cover things that you're interested in. So I'm quite keen to make sure that, all of you to attend, you get everything that you can out of this module. Okay. So drop me a line. I'll be happy to talk about things. I'm happy to take requests if you want anything in particular. So with that being said, thank you very much for attending today and for doing such a good job with finding wind turbines and purchasing some. We'll talk again on Monday. Bye bye.
Thank you.
Thank you very much. Bye.
Thank you. Bye.